Good evening, ladies and gentlemen. Your host, Zulu. So today we have one interesting discussion under Poisson distribution. So when we are dealing with Poisson distribution, we need to understand one thing. We need to read each and every expression that has been given to us in a mathematical way. So this expression that we have is reading as the random variable t, which is Poissonally distributed between lambda and the time. So when we are dealing with this, we need to understand one thing. We'll make this to be any non-letter, but we'll call it to be the mu. So the mu is equal to lambda times time. So with my mu here, I have replaced what is lambda and time with what? Mu. So I can rewrite this expression as this equal to that Pn with my mu here. So this is now reading to say the random variable t as a Poisson distribution with parameter mu. Then when we are dealing with the Poisson distributions formula, so the probability of x is equal to x equal to the exponent of negative mu multiplied by mu to the power x over x factorial, where x factorial gets any number starting from 0, 1, 2, and all the way to whatsoever we can go. So this is the formula that we'll be using when we are dealing with Poisson distribution, whereas in the probability x is equal to x equal to exponent of negative mu multiplied by mu to the power x over x factorial, where x can take any number. Where we need to understand one thing. This lambda which we have, it can be classified as events per unit time, events per unit time. Apart from this, we can have unit of volume or unit of length, whichever way you prefer, you can call it. So this is the discussion that we wanted to have before looking at some examples in calculating Poisson distribution. Your host, Zulu.